Jai Hind. Today we are going to discuss topic Google App Engine. Basically, it has been covered as a case study under Unit 5. Google App Engine, it is first released as a beta version in April 2008, and nowadays it is a widely used cloud-based application. Basically, it is your PaaS. It supports the PaaS environment. So here, Google App Engine, it provides the support for the platform, and it provides a complete web service environment. That is, you just log in, use your web browsers to access the services of GAE. Google App Engine, it provides web application development platform for users. All required hardware, OS and software, they are provided to the clients by the Google App Engine. Clients can develop their own applications while App Engines runs the applications on Google service. So your system is not being used because now you are on the cloud. It helps to easily develop a web application. It provides a powerful distributed data storage service. It virtualizes applications across multiple servers and data centers. Other than Google App Engine, we are having the PaaS services provided by Amazon and Microsoft, as well as Amazon also provided, and Microsoft Azure service, they are also providing their PaaS related services to the users. But here we are discussing only on the Google product. App Engine only supports Java and Python programming language. This is only two language support have been provided by the Google, that is Java and Python. With App Engines, Java Run JRE, you can build your app using standard Java technologies including JVM, Java servlets and the Java programming language, or any other language which basically use the Java JVM based interpreter or compiler such as JavaScript or Ruby. They can also run on it. App Engine also features a dedicated Python runtime environment which includes a fast Python interpreter, and it also provides the support of very exhaustive Python standard libraries which provide a very good support to the developers. Java and Python runtime environments are built to ensure that your application runs quickly in no time. You just write your code, and once you run it, it is done within few minutes. It is also providing a secure environment and without the interference from other apps on the system because you are working on the cloud. With App Engine, you only pay for what you use. So there are no, you could say, setup cost and no recurring fees required to set up the environment because all the thing has already been done by the CSP. The resources your application uses, such as storage, bandwidth, are measured by the gigabyte and billed at competitive rates. Various companies, they are providing it to you. You control the maximum amount of resources your app can consume, so it always stays within your budget. That is how many processors being involved for your computation, how much memory you need, all these parameters you can control. It makes it easy to build an application that runs reliably even under heavy load with large amounts of data. So the main features which this App Engine provides to the user is the persistent storage with queries, sorting and transactions. Automatic scaling and load balancing is there. APIs for authenticating users and sending email using Google accounts. That is, you can collaborate with other Google-based services. Task queues for performing work outside of the scope of a web request, schedule tasks for triggering events at specified times and regular intervals, dynamic web serving with full support for common web technologies. So the services which are being provided by the GAE is included here, shown here. So here we are having the Google App Engine, and this is the application through which you are interacting. Here we are having the SDC support, your enterprise data. So the communication between enterprise data and application is Google App Engine is also possible through the SDC. Similarly, other Google apps, they are also running and they also communicate with your application through this common SDC support. Here in the Google App Engine, these are the various components running, which we are going to discuss one by one. The first one is data store. The App Engine provides a powerful distributed data storage service that features a query engine and transactions. Just as the distributed web server grows with your traffic, the distributed data store grows with your data. So the App Engine store is not like the traditional relational database. Data objects, here we are calling them as entities, have a kind and a set of properties. Queries can retrieve the entities of a given kind, filtered and stored by the values on the basis of the properties being provided by the user. Property values can be of any supported property value types. Data store entities, they are schemaless, that is, no schema is being followed here. The data store is strongly consistent and uses optimistic concurrency control techniques. The data store implements transactions across its distributed network using entity groups. A transaction manipulates entities within a single group. Entities of the same group are stored together for efficient execution of transactions. Your application can assign entities to groups when the entities are created. So once you create an entity, it is being assigned to that particular group. Google account. App Engine supports integrate an application with Google accounts for user authentication. Your application can allow a user to sign in with a Google account. That is how you can use your application on the web browsers through a Google account. If you don't have Google account, then you can't use the Google App Engine services. Using Google account lets the user start using your application faster because the user may not need to create a new account. It also saves the effort of implementing a user account system just for your application. With the same Google account, you can access various Google services. URL fetch. Applications can access resources on the internet such as web services or other data using this particular component, that is URL fetch service. The URL fetch service retrieves web resources using the same high-speed Google infrastructure that retrieves web pages for many other Google products. Mail. Applications can send email messages using App Engine's mail service. The mail service uses Google infrastructure to send these messages. Memcache. The Memcache service provides your application with a high performance in memory key value cache that is accessible by multiple instances of your application. Memcache is useful for data that does not need the persistence and transactional features of the data store, such as temporary data or the data copied from the data store to the cache for high-speed access. Image manipulation component or service. The image service lets your application, it manipulates images. With this API, you can resize, crop, rotate, even flip the images in both JPNG and PNG formats. Schedule task and task queues. An application can perform tasks outside of responding to web requests. Your application can perform these tasks on a schedule that you configure, such as on a daily or the hourly basis, or the application can perform tasks added to a queue by the application itself, such as background tasks created while handling a request. Scheduled tasks, they are also known as cron jobs here, and basically they are handled by the cron service. Now the next is technologies used. That is what technologies are running behind your GA. The first and the very foremost is your file system. So Google is having its own file system, that is GFS, which is meant for storing large amount of data. Another important technology is MapReduce, which is required for application program development environment. Chubby, that is for distributed application log services. Bigtable, it offers a storage service. So the third party application providers can use GA to build cloud applications for providing services. Inside each data center, there are thousands of servers forming different clusters. And GA runs the user program on Google's infrastructure. Application developers now do not need to worry about the maintenance of the server, because maintenance part is handled by Google, because now you are getting the platform environment which is hosted on the architecture or the infrastructure of the Google. GA can be thought of as a combination of several software components. It supports, as we have already seen, only Python and Java environment. So if we talk about the GAE architecture, so here you could see we are having the application, that is your Google app, and here the user is sitting here. So here we are having the GFS master, who is controlling the all the file system over the you could say which is the controller of GFS Google file system. Here the scheduler is running, scheduling the processes. Then Chubby is there, and these are the various nodes. These node, now what kind of data is being maintained at these node? Bigtable server is there, MapReduce job is running over there, GFS chunk server is running over there, scheduler slave is also running on these nodes. And here you are sitting. So through the web browser, you are assessing the GA and how the GA is operating. It is operating through all these components. So GFS, we have already seen, it is meant for storing large amount of data. MapReduce, application program development. Chubby, basically for distributed application log services. Bigtable for storage devices when we are working on the structured data. So users, they can interact with Google applications via the web interface provided by each application. So here the user can use all these services if he has login on the Google App Engine. The applications all run in data centers under tight management by Google. Inside each data center, there are thousands of servers, and these servers, they may be forming different clusters. So a typical cluster configuration can run Google file. Each cluster is having a Google file system running on it. Similarly, MapReduce jobs, they are running on a single cluster. Bigtable servers for structured data, they are also running in this. So when you connect to the Google App Engine, you are connected to a typical cluster. Extra services such as Chubby for distributed logs can also run in these clusters. So when we say environment, our application can run only Python and Java. So we are having here SDK, web-based admin console is there, scalable infrastructure, and Java and Python runtime components are there. When you are working on the Java environment, then in that case, you can develop your application for the Java runtime environment using common Java web development tools and API standards. Your app interacts with the environment using Java serverless standards and can use common web application technology such as JSP. When you are working on the Python runtime environment, then with App Engine's Python runtime environment, you can implement your app using Python language and run it on an optimized Python interpreter. App Engine, which includes rich APIs and tools for Python web application development, including a feature-rich data modeling API tools and easy-to-use web application framework and tools for managing and using your app's data. You can also take advantage of a wide variety of mature libraries and frameworks, which is provided in the desktop version of the Python IDE, for example, Django. So the function, let's come to the next topic, that is functional modules of GAE. So here we are having the Google apps, then we are having tunnel servers and internet connectivity is here. Here we are having the corporate firewall. From here the data goes to secure data connector. Here the optimal firewall is working, and here the web service API servers, they are being operated. So when the user wants to get the data, he she will first send an authorized data request to Google Apps. That is, your data comes here. It forwards the request to the tunnel server, which is the next entity in this case. So what's the role of tunnel servers? They validate the request identity. If the identity is valid, the tunnel protocol, it allows the SDC to set up a connection, authenticate and encrypt the data that flows across the internet. SDC also validates whether a user is authorized to access a specified resource. Application runtime environment offers a platform for web programming and execution. SDK is basically used for local application development. The SDK allows the user to execute test runs of local applications and upload the application code. Administration console is used for easy management of user application development cycles. GAE web service infrastructure provides a spatial, guarantee, flexible use and management of the storage and network resources by Google App Engine. It offers free GAE service to all Gmail account users. This infrastructure provides a spatial, guarantee, flexible store for network resources by GAE. Google offers essentially free GAE service to all Gmail account users, which we have already seen, which we can register for GAE account or use your Gmail account name to sign up for the service. The service is free within a quota. If you want to exceed the resources, then you need to pay the extra amount. It allows the users to deploy user-built applications on top of the cloud infrastructure. And the basic two languages which has been supported here is Java and Python. So what are the basic GAE applications? Google search engine is provided to you. Google Docs you can use. You can collaborate with Google Docs. You can collaborate with Google Earth. You can collaborate with it. Google Mail Service. These applications can support large number of users simultaneously. Users can interact with Google applications by the web interface. Application run in the Google data centers. Inside each data center, there may be thousands of nodes forming the clusters, which we have seen already. And these clusters can run multi-purpose servers, which we have seen earlier. So what are the advantages of Google App Engine? First, infrastructure for security. The internet infrastructure that Google uses is arguably the safest in the entire world. Since the application data and code are hosted on extremely secure servers, there has rarely been any kind of illegal access to date. Faster time to market. For every organization, getting a product or service to market quickly is crucial. When it comes to quickly releasing the product, encouraging the development and maintenance of an app is essential. A firm can grow swiftly with Google Cloud App Engine assistance. Quick to start. You don't need to spend a lot of time in prototyping or deploying the app to users because there is no hardware product to buy and maintain. So it is very quick to start with. Easy to use. The tools that you need to create, test, launch, deploy, update your applications are already included in GAE. Rich set of APIs and services. A number of built-in APIs and services in Google App Engine enable the developers to create a strong, feature-rich applications. Scalability. This is one of the deciding variables for the success of any software. When using the Google App Engine to construct, you may access it like GFS, Bigtable, and other Google uses to build its own apps. Performance and reliability. Among international brands, we are aware Google is among the top ones. Therefore, we must keep one thing in mind, that it is that the Google provide a very good support in terms of performance, reliability, and security. Cost saving: to administer your servers, you don't need to employ engineers, because again, all the maintenance part, administration part, and the updation part goes with the Google itself, Google team. Platform independence: is the App Engine platform only has a few dependency. You can easily reload or relocate all of your data to another environment. So this is all about Google App Engine. A very brief introduction of the Google App Engine. These are the references which I used to prepare my slides. Thank you and Jai Hind.